Yeah.
Okay. Better do that. I don't want to run things.
Actually, I think you can just turn the whole hosting over to him now that you've done.
I'll just, yeah, I'll make John a host now. There we go. Ah, yes, the bumbling fools have finally got through it all.
There we are. Yeah, that's okay. This is about the time we normally start anyway.
So now I can let you.
I'm already recording.
Oh, you're recording.
Did that while he was hosting.
Good enough. That was tricky, but we're up to 30 people, guys. I think it's probably time to get started.
And I was going to say, we've only been doing this a year, so it's, we're learning.
So before we get going, I just want to say, it looks like the cafe is working rather well because we've got quite a lot of people that would like to say something or do something tonight. So to be fair about it, I'm going to take them in the order that they came in. And if we run out of time, we'll scratch the people at the end for next and put them on next week. But I don't know how long people are going to be, so we might have lots of time. But I'll just take them in order. So the first one is Chris Purse, who's going to do some announcements. Go ahead, Chris.
Sure, thanks, John. So just a reminder that our normal procedure is to skip holiday Mondays. So next Monday is Easter Monday, so we would normally be back on the 12th. I just mentioned that. No cafe next week. And the other thing is just a reminder for those who are interested in doing the moon observing program, that starts on Thursday. That's with National. And it's called the Moon at Noon, which means it's the moon at 9 a.m. for us. But if you're interested in doing that, you can sign up. They've also prepared a workbook to go with that to help record your observations. And that is the first certificate in observing the moon, not the one that Randy has just done. Randy previously did this one. So if you want to talk to somebody about doing this one, Randy can tell you about it as well. Thank you, John.
Okay, so let me just tell you the order that we're going to go tonight. Nathan is going to be next, then Randy, then Marjie, then Dave Robinson, Lauri, Brock, David, and anybody else? Okay, and me at the end, at the tail end. So if anybody gets scrubbed, it's got to be me.
And if we're bored, I can do the sky this week, but it's not that exciting this week. So just a regular feature.
Was that Dave?
This is Randy.
Oh, Randy. Okay.
But it's better to have content than to talk about how little there is to look at in the sky.
Okay, well, your choice. Anyway, Nathan is next, so go ahead. Nathan's got a few items he wants to do.
Okay, so first it's two pictures I made that I'd like to share. I guess I'll just screen share this. So my first picture is this picture I made by putting together some of my pictures of the moon. Notice like the whole moon is basically, I think it's called the Terminator. That's basically the entire surface is in that part. So I took pictures of the moon in all the different phases and then put them together. So it looks like there's all the craters are at that nice shadow angle. Now, this would only be possible in real life with a surrounding array of suns, but if there was a surrounding array of suns, we would all die. So this is the only way that we can get this image.
No, it's even better because the other suns would fill in the shadows.
True.
So how many photos is that?
I think that was 6.
Wow, well done.
Oh, thanks. My second one is what you see when you have really dark skies. So these days, the darkest skies one can see is usually just the Milky Way. But if you look at the ancient Greek sky maps, you can tell that they had really dark skies because the skies were so dark, they could even see the lines connecting the stars in the constellations and even the figures representing the constellations. Now, you can only see these under very dark skies, so it's sad that nobody alive today has seen these.
Bill Weir, you must have seen them. You got the sharpest eyes.
Well, the Greek star charts are memories from the past when we had really dark skies and could see these. All right, so now my final topic that I'm sharing is my annual science fair project, which this year is about water rockets. Now you might be wondering what a water rocket is. It has the same principles as a regular rocket. It's powered by water though, and I will share a quick video of my best water rockets just before I talk about my project. So this here it is. Can everyone see that?
Yep.
Wow.
Nathan, wow.
Well, Nathan, I've got to admit I'm impressed with the third item because that brought back memories because I used to fly water rockets when I was a kid.
But I used to fly
Nathan,
a-
how high do you think you got?
So I had an altimeter that measures the height, and my altitude record is about 100 meters. But it sounds more impressive if you say 330 feet. So I'll just say that.
That's
No.
pretty high.
So Nathan, I used to do water bottle rockets a lot too. So how do you figure out how much if for a single bottle, how much water do you put in for the best performance?
Thank you for perfectly bringing me to what I was about to say. This is the foundation of my science fair project.
Okay.
So, yeah, so I've been building and designing and flying water rockets for the past 3 years. And as you saw in that video, some of them have flown very high and straight. That was a very biased video, though, I've got to say, because I've excluded the majority of my flights, which have spiraled out of control and crashed. My project was about maybe finding the right level of water to achieve the best altitude of a water rocket. And so I did this by changing the water level. And my hypothesis for this was that if I increased the water level in the rocket, it would go higher because there would be more mass expelled out of the rocket downward. And so there would be a greater reactive force pushing the rocket upward. But at some point, the amount of water would begin to weigh down the rocket. So at some point, it would start not going as high. My procedure was that I increased the amount of water inside the rocket at increments of 100 milliliters at a time. And I measured the altitude of the rocket using a little computer called an altimeter. For consistency in the data, I flew 4 flights for each water level. Try saying that 5 times fast, actually. 4 flights for each water level. Anyway, so I kept all the other variables the same. So I kept the air pressure the same, which was 60 psi, the type of rocket the same, and the weather conditions were the same. So I only flew it on days without much wind. So originally I used this rocket for my experiment, which is just one of these bottles, but I soon found out that was not aerodynamically stable and it often tumbled after launch. So I switched to this more aerodynamically stable rocket, which was 2 of the bottles stuck together. And as you saw in that video, that rocket flew way higher. I started by recording launches with no fuel, no water, I mean. It sounds cooler when you say fuel though. And then 4 launches with the 100 milliliters, 200 milliliters, 300 milliliters, and then for the sake of alliterations, 4 flights at 400 milliliters of water, and then 500 too. Now, once I had measured them at 500, I plotted it out into a graph, and I can show you the graph here. Here is the graph. Now, oops. Okay, there was the graph. I don't know if you saw it. The
You want
interesting
more?
thing-
Show it again.
Right. Oh, here. Okay, there we go. Now let me just put that on full screen. There, so I had only plotted the part to 500 at the time, so if you just imagine ignoring the last 2 parts, I had noticed that though the altitude was increasing, it was increasing pretty steadily, like a straight line, so it wasn't really leveling out, let alone going back down. Of course, ignoring the other 2 because I hadn't done them yet. So I skipped ahead to 750 milliliters of water to see if I could reach that point more quickly. So I did 4 flights at that, and I found out that they were actually lower than the 500 milliliter flights. So I had already passed the optimal water level. So backtracking, I flew flights at 600 milliliters, and they fit pretty nicely in between 500 and 750, so lower than 500 milliliters, but higher than 750. I only got to fly 3 flights at 600 milliliters. The reason I didn't get the 4th flight, I'll tell you in this next section, which was everything that went wrong in the experiment. So a lot of stuff did go wrong, and I began to consider if the science fair project was cursed after the following stuff happened. So one of the bottles sprang a leak, and that's pretty bad if it explodes because it's pretty loud with all the compressed air, so I had to switch that out. That was okay though. We lost, or I lost a lot of fins of those red fins during the experiment. They are really good fins because they let the rocket float down gently, but they're the worst quality fins you can imagine. A lot of fins broke, and once we had ran out of fins, more fins had to be ordered. I had the idea of taping on the fins while I waited for new fins to arrive. That worked okay, but they broke immediately after the rocket landed. The average launch to broken fin ratio, I found out, was around 3-to-1, and on one launch it was actually 1-to-2. But more fins were ordered, and so I was able to finish the project. The pump broke, so I had to order a new pump, and that pump actually didn't work. So we had to get another pump, which we never had to use because we fixed the original pump. And also, like what was happening before, a lot of my launches actually veered off and tumbled and crashed, which I found out was due to the fact that the altimeter was mounted to the side of the rocket, which moved the rocket's center of mass off center. So it was actually attached here, and it caused drag on the side. So to fix that, I actually put the altimeter here instead, on the side here, which caused less drag. Now, I don't have the altimeter with me, and this is a good time to bring in what happened to that fourth launch at 600 milliliters of water. It managed to land itself quite inconveniently at the top of a very tall tree. We managed to get it down with a 40-foot long pole. The rocket was brought down safely, but the altimeter was nowhere to be seen, and we have yet to find it. So, yeah, that was it for that project. But I had collected enough data to come to a conclusion, which is that 500 milliliters of water seems to be the optimal amount for the rocket that I was using, which would make the water to air ratio 1:14. Then again, I only tested one type of rocket and only at one level of air pressure. So if I were to expand on this project, I would add more variables like the rocket size, the air pressure, and maybe even the density of the liquid. So I could try different liquids too. So in my research, I attempted to learn some of the equations involved in water rocket science. You can take a look at some of them here. I was not able to understand these equations, but I do understand why they're hard to understand, because in water rocket science, all the variables of the rocket are always changing throughout the flight. So unlike regular thrust and force equations, once the rocket is launched, it's losing water, so it's losing mass. And the pressure inside the rocket is decreasing as the water escapes and then the air escapes afterwards. So these equations have to take into account all of that, which makes them complicated. But there is one straightforward and fundamental law of physics that applies to water rocket science, which is every action has an equal but opposite reaction. So as the water leaves the rocket downward at high speed, the rocket goes upward at high speed. I'm thankful for that, because without it, obviously this experiment would not be possible. Anyway, that's my experiment.
Well, Nathan, congratulations. I have some very important questions for you, because I'm about to start launching water bottle rockets with my grandchildren soon. So I need to know from you what the ratio is. Like, it was the 500 milliliters was good, but how big was the overall volume of the water bottle?
Oh yeah, so this is a 7-liter rocket, so the ratio would be 1:14.
7 liters, 500, so half a liter to 7 liters.
Mm-hmm. But
So-
it's cool to experiment with different levels too, because I only tested this rocket, which is definitely not shaped like an ordinary soda bottle, or I have yet to see a soda bottle shaped like that, at least.
So 114.
So it might be different levels, but that was the one that was for this rocket.
Well, good.
Well, thanks, Nathan. Any other questions for him?
How did you hold the pressure and how did you launch it?
Oh yes, so I use a launcher that a bicycle pump is attached to, and it's a one-way valve, so I can pump air into the rocket, which is held down on the launch pad, and then there's a remote switch. Oops. Here's the launch. Here's the launcher. So the rocket can slide in like this, and then there's a remote switch that, when pulled, will release the rocket.
For those water bottle rocket enthusiasts, I have a homemade version of that I can share with you that works slick.
Oh yeah, there's definitely a lot of versions of those that I've seen.
Nathan, how many people did you have to talk to at the science fair?
I haven't had my interviews yet, but
Oh, okay.
at the field, I certainly had to talk to a lot of people, warning them that there were water-powered missiles being shot off.
Where did the farthest one land?
Oh, not that far off in my science fair, but in my history of launching rockets, one of them, I launched them at a pretty large field, but obviously not large enough, because one of them went off the field over the tennis courts, like past the field, over a parking lot past the tennis courts, and onto the road past the parking lot. Thankfully, it wasn't a busy road, so I could just run and get the rocket, but it probably traveled about maybe 150 meters downrange, so yeah.
Okay, well,
Nathan.
thanks.
So
Thanks
I'll
very
say,
much, Nathan.
Nathan, I'd just like to say, it's unfortunate that we can't have this alive at UVic. It would have been a great science fair project display.
I feel like that might be a hazard to the ceiling lights.
Oh, it would have been great. Could you make a comment about how you feel about doing this online versus on site? Because those of us who are not presenters but enjoyed the fair miss not having it up at UVic.
Okay, I will tell you all about it.
Okay, well, thanks
Oh.
again, Nathan. And Randy, if you want to do something, you're on.
Well, Nathan, that was inspirational, and thank you very much.
You're very welcome.
I am going to talk about, let's get this right. Oh my. I always do this. Hold on. Stop share. Okay. So, are you going to work? We're in the middle between the beginning of Passover and Easter this year. Passover started on Saturday night, and Easter is this coming weekend. And it's one of those cases where astronomy has a very practical use. It's been, for thousands of years, astronomy, one of the main things, other than astrology, it was important for timekeeping. And this was particularly important when it came to the dates of religious festivals. So Passover and Easter always are pretty close to each other because they are related in how they are defined. So the Jewish calendar is lunar. Every month starts on the first sight of the crescent moon. So just the day or so after the new moon. And in order to keep the 12 months of lunar months, so 29 and a half days, in line with the solar year, so that the Passover is always in the spring, what happens is they throw in an extra month every once in a while. And until the 4th century, I believe it was they would take a look in February and said, it's too early, let's throw in another month. And then by the 4th century, they had figured out enough how it works to actually define it. So every 19 years, they put in 7 extra months. Every 2 or 3 years, they put in an extra month. And Passover starts on the 15th month of that's called Nisan. So the first day is the new moon. So the 15th day is a full moon. Passover always starts on a full moon. That's just the way it's always assigned. Rosh Hashanah, the Jewish New Year, always starts on a new moon, just because of the way that they've defined it.
That's unless the new moon is on the Sabbath.
Well, okay, I'll talk a bit about that later on. And it's not the Passover that's affected by that. It's actually going to be Rosh Hashanah and Yom Kippur that are affected. Okay, so now for the first few centuries of Christianity, they just took the Passover Seder, which was in the Bible. You know, the Last Supper was a Seder. And so they just used the Jewish calendar. But by the time that Rome had become Christian under Constantine, they decided to separate themselves from the Jewish tradition. And they set this rule. They also were very keen on Easter being on a Sunday, which is what led to the Christian observance of Sunday as the weekly holy day. So just to get it right, Thursday night was the Seder, the Last Supper. Friday was the trial and the crucifixion. The important thing in Christianity is the resurrection, which happened a couple of days after that on Sunday. And so it is set to be on the first Sunday after the full moon, after the vernal equinox. But for ecclesiastic purposes, they define the vernal equinox as March 21st. They do not actually use the astronomical definition. They use a civil definition. And this became real problematic with the Julian calendar, which said that the year was 365 and a quarter days, because it was getting out of whack. It was about 2 weeks out of whack by the time that Pope Gregory was the Pope, and they changed to the Gregorian calendar. Okay, nevertheless, they are both based on the moon, the full moon, after the beginning of spring, but with the extra thing that at the Council of Nicaea, they decided to put it on the Sunday after the full moon, after March 21st. So I could not find a nice table that gave the dates of Passover and Easter, but I found a calculator online, and I just went through each year and made a spreadsheet of the number of days between Passover and Easter. And so what we see, this is from 1900 till 2021. So it's a pretty good sample. And we see that usually Easter is after Passover, but then there are these times that it's about a month earlier. And it's just because of these different calculations when the full moon comes after the vernal equinox versus when the Jewish calendar puts its intercalary month. So those 7 times every 19 years. So I did a histogram of the number of days. And what surprised me, there is what, 4 or 5 days that they're on the same day, but otherwise they're 1, 3, 5, or 7 days difference. Now I understand that it's not more than 7 days because Passover is always on the full moon. Easter is always the Sunday after the full moon. So it's always going to be within a week. But Bill pointed out the other thing about the Jewish calendar, which is they have set it up so that you don't ever have a fast on the Sabbath, because then you would have a day of rest where you'd have to then be ready with a big meal before the fast on the Sunday. Okay, so the Yom Kippur in particular will never fall on a Sunday. And when you do the other fasts and things, they jig it around because you've got that little bit of leeway because it's 29 and a half days. So you can add a day here or there and it doesn't really change things too much. So it's set such that you would get a Passover starting on Sunday, Saturday, not on Friday, Thursday, not on Wednesday, Tuesday, not on Monday, or Sunday again. So fascinating. I didn't know that until I did this little experiment. And then the other thing is that every about year and 6 or 16% of the years, then the two calendars are out of whack by a month. And that is because they are based on the same idea. You have to put an extra month in every once in a while, but there's the 16% of the times they're put in at a different in a different month of the year, a different year. That's what I found out about Easter and Passover.
Thanks, Randy. Anybody
I
want to
just had this
comment?
discussion at supper with my wife and son about this. That's pretty funny that you brought it up too.
What was their take on it?
Well, my wife was, so that's why Easter keeps moving around. She for 60 years she never figured it out, that it was really all based around the full moon and the equinox. Well, why would people? People don't look up.
That's right. Not nearly enough.
When I've done outreach, like just showing the moon, and I'll be parked there. What are you looking at? Oh, the moon. Would you like to have a look? And then people will look up in the sky and say, oh, is it up?
Right.
Randy, thank you. I didn't realize the month-long differences between the Passover and Easter. I knew about the Easter stuff, but I didn't know that there was such a range, like every 6 years or so between the two. So thank you. That's
I
good.
knew about it, but I never actually took a close look to see how often it happened. That was what was new for me.
Yes, thank you, Randy. That was very interesting. I had known about the date being on the first full moon after the or the first Sunday after the first full moon after the equinox, but I hadn't realized that it was the civilly defined equinox as opposed to the astronomically defined. That makes a little bit more sense about how it got out of sync for between the Julian and Gregorian.
Yeah, the trick there is, once the Christian realm got to be big, it became important to have a rule rather than just have runners saying, it's coming up next week. I think there was also a very big anti-Semitic sentiment in that there was just this whole decision to separate themselves from the Jewish practice, even
They had
though
to.
very, very clearly explicit that Jesus was Jewish and all the traditions that he grew up in were Jewish.
Mhm.
But that's a whole other topic.
Yes, so that's one that's probably not best to get into right now. But the one I was interested also in the lunar calendar, the Jewish lunar calendar, being based on the start of the months being based on the crescent moon, because that's one thing I did know about Ramadan and the Islamic calendar, that that's set by the first sighting of the crescent moon in Mecca. And so now I know there's
It's
more than a bit
trickier
of
than that, Jim.
there's a bit of debate about.
Every country has their own committee.
Yes, that's true. Yes,
It's really important and I have a friend in Morocco. He says, "Oh, we have the best astronomers in Morocco." There's a big national pride thing in there. The Jews have also set that, so there is a calculation, but certainly in the early days, it was a committee that would look up and start the month when they saw that first crescent.
yes, yes. I know
It's lucky this
different.
wasn't. It's lucky this wasn't done in Victoria, where we can't see the moon a lot of the time.
Well, yeah, and Islam, the whole idea of doing Islam in Yukon, for example. I mean, they didn't design it for certain places.
Right.
I worked with a gentleman who observed Ramadan at one point, and I felt so sorry for him, because at the time I knew him, it was falling in the middle of the summer. So the poor man had to do the complete fast of food and water, over the summer daylight hours, which was like 18, 19 hours at the time. So, but he was quite philosophical about it. He said that when it got around to the winter months, it was much easier, and that made up for it.
But many of the imams in those northern places tell their people to go on Mecca time, so that they will just do it by the hours of the day that would be in Mecca.
In Yukon, they use Vancouver time.
Yeah. And the Wasanic people ran their lives by the moon.
Oh, yeah.
And they recognize that some years there are 13 moons. It's in their calendar. It's in their moon calendar that there are 13 moons, usually 12, but every once in a while there will be a 13th moon. And they ran their culture around it. That's the people of the Saanich area.
Okay. Are you able to give us a presentation on that sometime, Bill? It'd be really good.
Possibly. I don't know if I can get access to the full charts and all that anymore. It was written by a man who was an elder in the Saanich area, but he died a few years back. And so it's not my right to tell their story.
No, but
A couple of years ago, we did put those names in the RASC calendar for the full moons. They did the Mi'kmaq for a few years, and I don't know if it was this year because I don't have the calendar, but I do know that the 2020 calendar used the Wasanic moons. And it was actually a year when there were 13 full moons in the year. So it fit right. But I got permission from the family of Earl Claxon to use it in the calendar.
Bill, I do remember a few years ago, and actually preparing one of our bookmarks, and I think from Lauri may know more about this too, that there was at the time a site where a basic description of the lunar cycle and the names was given, and that's the extra moon. Now, I don't know if that's still available and it's not the same thing, but it's something that if people are interested, and the link is still there, it could be circulated.
It was on the Race Rocks website, but every time when I've tried to go look at it, blocks some things now. I don't know why.
Mm.
And because it was a teaching program thing. Lauri might know more about that.
Yeah, I
There
was
was
just going to say that it is a published book, and
You
the schools use this. And so because it's been published and is public, it can be used by people. I mean, it would be nice to get permissions, but this is one program that you actually do not need to go and get specific permission to do.
it's hard to find. It's hard to find the book.
When you don't, so.
I got a hold of it once and I photographed every page. But there's also a teaching guide that goes along with it.
Yeah, it's still available. Yeah. So,
But you can't
we
buy
could
it.
do something with that another time, Randy. Yeah, or John. Yeah, we could try.
Okay, well, thanks very much for that, Randy. And let's move along to Marjie now, who has something to share with us.
Just a comment in passing before you go there. That reminded me of a church we visited in Strasbourg, which, if you can see, there is the Christian clock for determining when Easter is. A mechanical clock that determined all of the ecclesiastical dates in this church in Strasbourg. It was just fascinating.
Yeah, I've been there, Dave.
I've been there. It's wonderful.
Yeah.
Okay, Marjie, you have something for us.
I do. Thank you. May I share the screen?
By all means.
Oops. Whether that did it or not. Share screen. Okay. There we go. All right. That works?
Yep.
Righty. Okay. The Kalamazoo Astronomical Society 5-part course is now completed. And hopefully soon I will receive a certificate in the mail for showing up for all 5 presentations. Very exciting. And so I asked Joe if we could put the information on the website, and he very wisely suggested that I write something about it. So I did that, and you can read it. And what I want to point out to you is that Richard Bell has given course participants permission to share his 5 lectures. So if I click on share his 5 lectures, we come to YouTube, and all 5 of them are there. Our Place Among the Infinities, Discovering the Night Sky, Binocular Basics, Telescope Tutorial, and The Art of Astrophotography.
Great.
And, just a second here. There we go. So that is there. And then starting on April 6th, of course, our 5 lectures were free. The 900 people who attended over time, well, not over time, over on each presentation, had the course for free, the presentation for free. Richard Bell has given, he's going to have an upcoming paid course, my introduction to astronomy. It begins on April the 6th and will extend over 11 weeks. It's part 1 of the course I took, but with a lot more detail is what he said. And there are exams if anybody wishes to take them. And the course is about, I think, $150 US. There is a syllabus which explains what is going to happen. And so people will meet on Tuesdays and Thursdays at 6 p.m. Eastern Daylight Time on Zoom. So there's a welcome to an explanation about what he's going to cover, about him. class schedule, et cetera, et cetera, et cetera, 4 exams if you wish to take them, and then a course syllabus. So here is what he is going to do over those 11 weeks. There we go. Pretty comprehensive. And if I can find my way back out of here, that's it. If I can find my way back out of here. I just closed that, I think.
That's
There
it.
we go.
You
I
did
did.
it. Thanks, Margie.
You're welcome.
Margie, did you learn a lot from the course? Did it change how you look at the sky?
Well, I did learn a lot from the course. I said in the written article that there were a lot of things to which I'm now in my 4th year with RASC. So there were a lot of things to which I realized that I have been exposed between RASC and RASC meetings and Astro Cafe and APOD and just doing my own down the rabbit hole research when there's something on APOD or something in the news to look at. So I had been exposed to quite a number of information, quite a bit of information. And then there was the rest of it to which I'd never been exposed. And it was, I'm glad I didn't have to take an exam on it. Yeah.
Okay, well, thanks you very much, Margie, for that. Dave Robinson, you've got something for us, and I think Chris has got the
Yeah,
images for you to show.
Yeah, Chris has the pictures he can bring up, and I can talk about them a little. So the first item, well, you can read the text there. This is taken by Arnold Rivera in the middle of March. It's the Propeller Nebula. The first one he took was a black and white, but he managed to get enough data to show it in color. So this was taken with his fancy 8-inch Celestron Row Ackerman, and done some stacking, and it turned. I'm amazed at how crisp the star and round the stars are in this. He must get excellent polar alignment. Then the next, this is the Leo Trio by Abdur Anwar, and I've got a later one that if we have time, I'll show you later, that he has gathered additional data that he had taken previously, and he's got that image available in color now.
Okay.
Oh yeah,
now
now
if I can make this work.
They had a really bright aurora in Edmonton, and it was spectacular.
Is that showing up all right?
Beautiful,
yeah. Yeah, you don't very often get those coronal aurora like that, and when you do, they're very purple. They have a lot of purple color in them. I've seen them a couple of times out at Blackfoot staging area. And that would be looking almost straight up.
I saw one in Saskatoon like that way back in the 1950s, I think.
Yeah, when it's that strong, quite often you will see aurora to the south of Edmonton, in the southern part of the sky. Really spectacular.
What I saw was straight overhead, the same as you described this one.
Yeah. That's quite the display, I'm sure.
Mm-hmm.
And that was taken from downtown by Abdur. That's from the light polluted center of city of Edmonton.
Wow.
That's quite a photo, isn't it?
That's impressive.
And then these two were taken by Alistair Ling, and it's a solar halo taken during late afternoon, I would guess. Probably ice crystals in the air. You can see a couple of tangential arcs plus the whole halo around the sun.
Nice.
That's it.
Now I'm going to see if I can share screen here.
Sure.
Let me just see if I can find, because I've got a couple of things that I can maybe, if it's going to come up. Maybe not. Come on, share content. Ah, here we are, screen. Okay. Zoom. Well, I guess. That's a problem with working on an iPad. Oh, here we go. Can you see that?
Not come up yet.
Set. Okay, let me have another go at this. If it doesn't work, we'll. Come on, come on. Sorry, can't get it to work through my iPad. I'll forward the next ones because
Sure,
there's a couple of interesting images that one is I'll forward it tomorrow. The one is the color picture of the Leo trio. Another is an image that was taken of a transit of an international space station across the face of the moon, and it shows the whole track across the dead center across the moon. And the third one, I think Randy will be interested in because Anwar says that he never recognized the lady in the moon or the man in the moon, but he does recognize the Tyrannosaurus in the moon. And he's outlined it on an image of the moon. You might
Hey,
find
we
that
got to see that one.
Yeah.
So get it to Chris next week. Or
Yeah, will
the
do.
week after.
Yeah, will do. There you go.
Okay, Dave, thank you. Lauri, you have something to tell us about.
Yes, thanks. Thanks, John. I've got two things. The first is about International Astronomy Day, and so if I could just, I'm hoping that this will work. Let's see if I can do this. The International Astronomy Day is going to be on Saturday, May the 15th this year. And we started a little bit of a group to do some planning for this, because obviously we can't be down at the museum or up at the center like we have been for the past few years, which is a shame. But we thought we'd do something online, a complete program online. And so what we've done is to get onto the national RASC webinar account. And we have the Zoom programming for that night from 7 to 11, and but we can use whatever we want of that time. And it will be a webinar, because what we'd like to do is have as many people come from the public through the RASC, through UVic, through the FDAO, through NRC. We want to widely publicize this, so that we get quite a number of people coming on. And we thought that it was probably best to do a webinar rather than try to fit everybody into a meeting. It gets a little unwieldy sometimes if there's, this is a lovely group of 30 or so, but as soon as you get more, it gets to be too many people. So we've pulled in the webinar. And what we had a short meeting yesterday, and I'm hoping that some more people will be able to come in and join us on our planning meeting, because we need some more people for ideas and for some things that need to be done. So we're really hoping that the RASC will some people will help. I've got Sid and David on board, but I would love to have some other people. So please let me know if you're interested in helping out. Just for now, this is absolutely in draft. This is not anywhere near ready whatsoever. But what we're going to try to do is start off the night before the main program starts, of having some streamed solar viewing from the deck of the CU if we can. And Sid and David are going to help out with that, as with the EAA group. And then starting at 8, we'll have our kind of, hellos and welcomes and introductions and stuff like that. And then Kim Venn is going to be our main speaker from UVic, and we're going to have her just speaking for half an hour or so with a little bit of time for discussions and questions. And then after this, for, I would say 45, 50 minutes or so, we've got a variety of some short programs that we'd like to put up. So for instance, I'm just kind of thinking about what might have been up in the museum. We'd love to have an astrophotography display of some of the really nice things that that all of you people do. It's just absolutely fabulous. We'd like to put up, we'd like to have a stellarium program of what's up in the sky, and maybe some of the, a couple of the RASC people might want to put on something like that. We would like to do a little bit of a planetarium show of some Indigenous astronomy, and actually just live stream it right from the planetarium at the CU. UVic is going to be invited, and some of the students might actually want to do a little bit of some live streaming on a little bit of a UVic tour of the telescope, which we could work out. So we've got a variety of things in here that we would like to put in, and this is where we really want to get some really good ideas from people as to what we should be doing. We want it to be lively and interactive, and something that people have fun with a little bit. And then at the end of the evening, when it gets dark, and we can do this, we're going to think about the live streaming from the CU deck and from the plasket, so that we could open the plasket if the weather is permitting, and from the UVic telescope if we can do that as well. And of course, then we have to have a total plan B if the weather doesn't cooperate. But the EAA, David's already told me that he's trying to get the EAA group to do some pre-recording and some videos. And we can even do that at UVic, and we obviously have got some plasket things as well, so that we can still have some programming here. And what we're kind of considering is that people might not want to come to all of this, or they might dip into one part of it and then leave for a little while and then come back in for maybe some of the live streaming, or whatever part they want. It won't be a problem. But I would really like to have a couple more people to help out. Nathan, are you still on for Ask an Astronomer?
Yes, I do think
Oh,
so.
awesome! Thank you. And I'm going to be asking specific people to help me with some of the things that I know that we'd like. But I'd love to have some more people. We're going to be having another meeting in about another 10 days or so, and I will put out another call. So thank you. Thanks to everybody who's already said that they would help, and we hope to get some more people involved in this. So not quite down at the museum, but we'll see what we can do with that. Okay, so I'm going to stop my share there. And then the other thing that I wanted to tell the group, Reg, you'll be thrilled. We have, the FDAO has just purchased and has set up a complete set of industrial shelving in the middle room of the CU. And so we would like to invite the RASC to kind of re-look at all of the boxes and all of the bins and everything else that was in that room. It's now actually in the hall. And because we've now got some shelving that we're going to share between the two organizations in order to have everything off the floor and into some really nice shelving in there. So I will be asking people. I know that Reg, you were part of that. I think Barb was part of that. Who else helped, Reg, to do that fixing up and collaborate? The collaboration of that.
I think it was mainly you and me, Lauri. But that's great news. And let me know when you would like me to help out.
No, it's just because that's just been kind of accumulating more and more and more, and it was wild. So anyway, the shelving will really help. So I just wanted to invite people to maybe have a little bit of a chance to get up to the center and get some things organized up in there. So Yay. This is all good news for us. So thanks. That's all I wanted to say. Thanks, everybody.
Shelves sound like very good news for Lauri. Thank you.
Very good news. Yes.
Yeah.
And sorry. Lastly, we set them all up on the like last Friday, and then on Sunday it took 2 days to get these all put together. And then I emailed Derek Mann and Alex McDonald up at the center and asked this morning whether or not within the next couple of weeks they could anchor them to the walls, because we didn't want to do the anchoring for doing something wrong. So we asked them to do it, and we said, could you do this within the next couple of days? And we got an email back about 1 o'clock in the afternoon saying, all done.
Wow.
So it was amazing.
That's good.
got it all anchored to the walls and everything for safety. So all done, ready to go. Yeah. Thanks.
Okay, Lauri, thank you. It's good news. Brock, you have something to show us about finding novas.
Can you see my screen?
We can, Brock.
Okay, good. So, yeah, David Lee had mentioned that there was a nova that was visible up in Cassiopeia, and there were some articles about it. And hold on, gotta be able to change views here. I can't seem to advance my slides. Hold on. There we go. So anyways, there was some articles that nicely enough gave some information on it. And the key piece of information was, of course, the coordinates and right ascension and declination. But so I thought I would give it a go and see if I could actually find it. Zooming in here, I was looking at the star pattern and trying to figure, if I do get in this zone, what am I actually trying to actually see here? And I was able to actually find, there's a little pattern here that I was looking for. There's 2 reasonably bright stars and there's a little triplet. And I was sort of like, I got to keep my eye open for that little cluster of stars. So knowing that, I got out my trusty scope. And the reason I mentioned cheating is just because this ASI Air made things a lot easier. This is a little Raspberry Pi device that weighs it's about the size of a deck of cards. You can see it on my scope way up at the back here. And it basically runs the mount. It's got power outlets for the dew heaters, and you name it, it does it. So all I really had to do was input the coordinates into the little display here, press the green button, and my mount slewed, did a bit of plate solving, and there it was. It was actually not too far off. It wasn't directly on target. I actually, when I clear the screen, I could actually see those 2 bright stars and that little triplet right here. And they weren't really in the center of field. So when you actually go back, if you're in this little screen and you just touch with your finger on your tablet or your phone, somewhere out here, everything goes away and you just see this open field. And if you click one more time, it gives you this little go wherever you clicked, and then it'll re-slew to center that and put that right in the center. And now this is the next preview. And you can see that that same 2 stars are now right in the center of the field of view. So I set up some 30-second exposures, and I didn't actually do any darks because I was just gonna rail the settings so that I'd show the stars in a nice black background. And basically got it tracking and took some shots, and then I put it through Deep Sky Stacker and did a bit of work in GIMP. And there we go. We've got the nova right dead center there, some crosshairs on it. And you can see that same star, that triplet with the 2 bright stars. And I overlaid the article back and forth between the article in the magazine and the image that I was able to capture. and was able to pretty much confirm that I nailed that target. So it's pretty neat and remarkably easy given some modern technology. And just for fun, I overlaid my field of view of my scope onto the article's image. So I actually could see the this really bright star here was, I guess, this one up here. And I didn't have enough field of view to catch the bubble nebula, but if I had a wider field of view scope, it would have been fun to get that too.
That's really neat.
So, Brock,
I can see why you like that machine you're using.
Sorry, Gary?
Brock, which program actually generated the stuff on the screen? Is it the ASI Air? Has a program?
Yeah, the ASI Air has an app, and the app is basically runs on your phone or tablet, and this is just a screenshot from my iPhone. So you just open an app and it connects over the network. It uses either Bluetooth or there's an Ethernet port on the ASI Air. And you can connect to it, and it does plate solving, it does the tracking, controls your dew heaters, does pretty much everything. It's pretty
How
amazing.
does it connect to your mount?
It connects with the USB.
That's pretty sweet.
Yeah.
This
Yeah.
is the next generation in telescope control software.
Yeah, I mean, you don't need, you know, you're not, and I'm sitting in my nice warm house, right? So, you know, as opposed to sitting, you know, on a little stool out by their laptop that's covered in dew, you know.
No, you're supposed to take a photograph of yourself out there freezing to death and show that to people, and then don't mention that you're in the house.
Yeah, I'll get a stock photo of somebody doing that in the demo and tell them it's me.
Brock, can the ASI Air hook up to digital single lens reflex so you can use the timer?
Yeah, that's actually exactly what this was done with. I have there's a Canon, you can see in the picture, there's a Canon T3i on the back there. So the guide, it's a ASI guide camera and a Canon T3i all plugged into the ASI Air.
So part of the cost of an intervalometer, if a person doesn't have one of those, they could apply it to an ASI Air instead.
Yeah, absolutely. Yeah, it definitely makes it easy. It also saves you buying a dew heater or a dew heater controller.
The plate solving, is that done online using the ASI Air, or does it have a database built into it?
It has its own database, and I haven't had any problems with it plate solving, and that's with it's a 2350 millimeter telescope with a 0.7 reducer. So I haven't done plate solving with the full 2350 millimeters. I don't know if it can quite do that, but it has no problem with the focal reducer on the telescope. So
That's quite lovely to get plate solving in a little bundle like that.
yes, yeah, and the ability to recenter, like if you're trying to, you know, you want to, it's not on target, you just click where you want the center, and there it is, it's moved, you know.
There you go. What more could you want?
So. Anyways, that's about all I wanted to show, but it's I think the title frame is quite accurate.
Thanks very much for that, Brock. That's quite interesting. I notice also your scope is doing a nice job. You had lovely lovely star shapes and nice color in them, which I like.
Yes.
Yeah.
Yeah. I'm actually running my ASI Air as we speak. I've got I've got it. I'm running it on. I don't know if you can see this, but it's actually running on a simulator. I've got it running on Nox Player, which is an Android simulator. So this is actually running right now live outside. I'm actually taking some darks because I didn't want to stay up late enough So, but it's too moony to do anything useful. So I'm just running a whole pile of darks. But
That's pretty neat.
Very good.
Okay, well, thanks very much. David, you're next. David Lee.
I'll be brief here. Let me just share my screen. So we have a what is called a lunar occultation coming up, and I don't know how many of you have sort of experienced this, but it's quite cool. I've done a number of them in my past, and even if you don't have a telescope, this is can be quite visible with a pair of binoculars. So I really encourage people, if you want to know more information, just send me an email. I probably will do a presentation closer to the event. So it's happening on the 23rd. It's a Friday night. It's going to happen just a little past 11 o'clock, and the star will reappear on the bright side of the moon about an hour later. So it's quite a bright star. It's Mag 4. So it's about the same magnitude as the stars in Auriga. So if you can see those from your location, you shouldn't have any trouble at all. So just let me know if you're interested, and then I'll give you more information. I will have a presentation in the coming weeks. You can probably see the URL at the bottom there. I'll see if I can scrape that off and throw that into the chat as well. So yeah, if you have any questions, just let me know.
David, one thing I'm noticing right now is that if the picture on the left shows just before the start of it,
yes,
it looks like it's going to disappear when the part of the moon that's occulting it is not visible. It's in the dark.
Correct. So
that makes it kind of interesting.
Oh yeah, it'll make it even more fun.
Yeah.
You can get the exact timing from the occultation website. I think I would start looking at maybe like 5 past. It's probably going to happen in, one thing I should mention, the timing of the disappearance and the reappearance depends on where you live. And it is visible here on the west coast. The predictions are it's going to be probably around 11:15. So I would start looking at around maybe 11:05 or 11:10. I'm probably going to even video it actually. Yeah, it's going to be really kind of cool. These kind of occultations are probably even more interesting when something called a graze, and that's where it's really, really close to the edge of the moon, and then you'll see it being on and off, and there's a lot of information to derive from that.
Okay, well, thank you very much. Everybody's been very efficient tonight. It's only 8:45, and we've got through that. Does anyone else have anything before I do a little bit of stuff? Okay. Well, by being that efficient, you're subjecting yourself to a bit of physics tonight. Sorry about that.
I love physics.
Good. So, let me just play this from the start. You should be seeing something now called Black Holes Get More Interesting. Can you see that okay?
Yes, we can.
Okay. So before I start this, I just want to say my interests are probably a little different from many of you in that I've done physics for most of my life. And I'm actually less interested in the parts of the universe that we can see, even though I love taking pictures of it. I'm really much more interested in the parts that tell us about things that we don't yet understand. And in recent times, there's been a lot more observational activity directed at learning things about black holes. And that really took off when they were able to get the gravity wave signal from two large black holes colliding. That happened in 2015, September. And it makes something even more special for me because my grandson had done the simulations. He led the group that did the simulations that showed what the signal was going to look like. And it turned out those simulations were pretty accurate. So I was quite excited about that. At any rate, what I want to show you right now is that there hasn't really been up until now a lot of sort of accessible information about black holes because they've been studied by people who are, doing theoretical physics of a sort of extreme kind and not always the kind of people that do a lot of explaining about it. But there is some new information emerging, and I think this may be the first time in my whole life that I'm actually highly recommending a magazine that Scientific American put out. It's just come out. It's called Black Holes, the Extreme Science of the Universe's Most Mysterious Phenomena. And it's an amazingly well done publication. It's got articles on many of the latest results. It's got quite a large number of articles on different aspects. I'll give you a summary of just one or two of these, just to give you a little bit of an idea. And if some of you get into it, get one of these magazines and start looking at it, and you want to talk about it more later, we can do that. But what I'd like to show you now is, let me just start by showing you, this is a picture from one of the articles on the right here. And so let's start out by just reminding ourselves what a black hole is. So you imagine a mass of material being squeezed into an unbelievably tiny space. Its gravity will affect everything around it, just like any other mass. But near the object, the gravitational force can get extreme, can get so large, especially if there's a fair bit of mass in that thing. And once an object gets closer than a certain distance, it really can't get away. And the picture shows a star coming in, star starting up here, coming in, starting to get tidally disturbed by the very strong gravity, and then eventually sort of shredding. And some of the shreds get pulled into the black hole and end up making a ring around it. And some of it, as you can see, gets thrown out. And it's the stuff that gets thrown out that we can see. So what the thing will look like is shown down in number 1 on the bottom left when it's being shredded and pulled in, and it gets very bright for a while. And then in the aftermath, once the material has been swallowed by the black hole, it just goes dark again. So that's what black holes do. I got asked by somebody in Ross Place just this week, aren't they like vacuum cleaners that are going to eventually just vacuum up the whole universe? And the answer is no. Stars that are beyond a certain distance from the black hole will just orbit in relatively stable orbits and not get pulled in. And we know in the middle of our Milky Way, there are quite a number of stars that are going around that have been imaged. And the Nobel Prize this time went to 3 people, one of whom was a woman that had studied the orbits of those stars to show that it really meant there was a black hole in the middle of our galaxy. By the way, if you have questions while I'm doing this, just go ahead and ask. If I don't get finished, it's okay. So the gravity waves from the collisions, because so much material is being moved around the black hole so quickly, it's like an oscillator, and it actually wobbles space itself and sends out gravity waves. And September 2015 is when they first were able to actually observe a gravity wave. They've observed many, many since. And not all of them are black hole collisions. Some are neutron star collisions, or you can have a black hole and a neutron star colliding. But you can learn an enormous amount, it turns out, from the shape of the signals. And you can learn things like the mass of the black holes that are colliding. The first two turned out to be roughly 30 solar masses each, which was larger than they expected to be able to find. And I'll say more about that in a moment. It's also possible to derive precision astronomical distances from the combination of gravity waves and telescope observations. So what they've done is they've set up very fast notifications going out. When they detect one of these gravity waves, a lot of the observatories around the Earth will get the signal and immediately start looking for the possibility of electromagnetic waves coming out from the same object. And they have managed to see that sort of thing. Now, some of the findings are turning out to be very surprising. And I'll just give you a brief overview. So one of the puzzles is that the colliding black holes that are seen are so large, and the more they find that quite a few of them are really quite large. Now, why is that surprising? Well, there's a limit. It used to be thought that black holes all came from the explosions of dying giant stars. But there's a limit to how large a black hole can be produced in that way. And many of the objects are sort of right at the limit or even beyond the limit a little bit of what should be possible that way. And that's weird. They were expecting to find a lot more smaller ones. So one of the ideas that's been advanced to solve the puzzle is a proposal that maybe the black holes are actually primordial. That is, maybe they came out of the Big Bang before stars and galaxies were even formed. This is it's a new idea, it's a controversial idea, it may not be correct, but I just find it really interesting. And it turns out, if you read the article about this in the thing, it describes all the different puzzling features that seem to be fitted by this kind of a proposal. So it's probably going to get examined very carefully, and sooner or later we'll know if this is true or not. Another thing about it is that if there are black holes produced by the early universe, there may be an awful lot of black holes throughout the universe. We wouldn't necessarily see them. There was a proposal back in the 1970s by Stephen Hawking and Bernard Carr that black holes might be what dark matter is. And that looked promising for a while. They called the things they were looking for machos, just because they were large, heavy things. But the idea kind of lost flavor when microlensing observations, which should have been able to see the black holes the size stars produced, didn't see any. It turns out that the ones produced, if the ones are produced in primordially in the Big Bang, they cover a much bigger range of sizes, and some of them are much bigger than the ones that could have been seen by microlensing. The other thing that is true is that if they were formed in the early days that way, they probably were formed in clusters. And if they're in clusters, there could be a lot of empty space where you don't see any black holes, but there would be still a lot of mass because they're clustered. So one of the things that will be looked for in future gravity wave detection is whether they get a sort of a spectrum of masses of stars that fits with the modeling that's been done for these primordial black holes. And I think that is going to be an interesting thing to watch for. Now, there are lots of other puzzles that are starting to be resolved. And some of them are shown in this article on the right. There's a whole lot of puzzles. One is the problem with general relativity and Hawking radiation that is related to the fact that quantum physics and gravity or relativity don't seem to be compatible with each other. There may be some ways that is starting to be resolved, and there's an article about that sort of thing in the book. So in fact, there's several articles about quantum physics and relativity. There's also articles about something called a firewall that may form around black holes that prevents us from knowing anything that's going on inside or outside. And we now know because of quantum physics, there has to be stuff going on inside. So lots of stuff to read in there. I'd be happy to talk to anybody that wants to read these things and comes up with questions. I might not be able to answer them, but I could try. So that's what I wanted to show you. I've got one other thing that I would like to show, just briefly. How's our time? 9 o'clock. I won't cut myself off quite yet. What I would like to show you is just this is for Randy. Are you still here, Randy?
You bet I am.
Okay, this is for you. This is a picture of the moon just a few days ago. 2021-03-25 at 8:13 p.m. And you can see it's not full, but it's getting close. And then we've had a few clear nights, so I thought it'd be fun to take some pictures just showing the change through the full moon phase. So, whoops. Sorry, I didn't do that very well. Got finger troubles here. Yeah. Here's the next one. And it's still, you can see it's still not quite full, but it's getting very close. And here it is just past full. You're starting to see the edge over on the other side now. This was taken last night, I guess, at 11:49. And that's about 12 hours after the actual full moon. I just thought it was kind of fun to get a sequence like this. I would love to get a sequence of the moon at short intervals by doing it every night for a month, but I don't think Victoria weather will ever allow me to do that. Anyway, that's what I wanted to show.
John, were those stacked images of the moon from a movie or a single
Actually,
frame?
they were not. That's the other thing that's kind of interesting. Let me just put the first one up again, because it's better than I thought it would be. This is a DSLR single shot.
That's amazing.
But the seeing was not good visually. But what I did was I set the shutter speed to 1/1600th of a second. And the moon is pretty bright. So you can shoot with pretty high speed, and that speed seemed to stop the motion well enough to get a pretty sharp image.
John, did you take single or did you blast it and the whole bunch?
What did you say, Randy?
No, it's David here.
Okay.
Did you take just a single shot, or did you take
Just one
a
shot,
series?
just one
Just one.
Hmm.
Okay.
in each
But I-
case, because I was trying to beat the seeing. We've had a lot of wind in the last few days. And the
Yeah,
seeing
this
has
is-
been pretty bad.
But this is surprisingly good. A couple of days ago, I was doing the same thing, taking single shots through my little C8 with my Nikon, and it didn't come out anywhere this nice. So you're doing something right there, buddy.
What
Well, maybe
time
you
of
have
night
to-
was that?
That was pretty early.
Yeah, this one was at 8:30. Whoops, I keep doing that. Sorry.
Yeah, mine was around 9 o'clock, 10 o'clock.
This was 8:13. Each night, of course, it's a little later. I tried to get it at about the same place in the sky each night.
Oh yeah.
So this
John?
one
I
was
was out a little
10:59,
later.
and this one was 11:49. And if I do it again tonight, it'll be after midnight.
John,
Yeah.
can you go to the 26th and zoom in to just above where it says 2021? And then I'd like to show my sketch of the same region.
Sure.
So just move that up a bit. Up, 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 up. Okay, so that is Bailey. That is the largest crater on the near side. And then if you let me share, I'll show you my
Okay, I'll just stop the share.
and here is my sketch of the same.
Oh, very nice.
It was wonderful. It was really
Nice.
and it's very rare that you get to see the craters within Bailey. They're usually just glancing. There was a very good libration, so it was really
Right.
brought towards us.
Right. Yeah, you must have been doing it at just about the same time then, eh?
I hate to say it, I was doing that at 4 a.m.
Oh, were you? Okay. So later. Same night or?
Yeah, this is just a few
Yeah,
hours
okay.
after you.
Okay.
And the seeing really was very good.
You're seeing actually a bit further into the edge there, I think.
That's right.
Yeah,
It will have moved, 4 hours since
a little bit.
the
Yeah.
time of yours. So if I unshare, just everybody memorize that. And now John put it back on.
Okay.
Yeah,
Did you
that's
see
it's
that?
very rare that we get to see inside that crater so well.
Right.
I have some video of that night too, I think.
Oh, good.
John, can you just zoom back out just a little bit?
Yes.
And, sorry, and go to the first one,
Okay.
the 24th or 25th, what was it?
Got to find my,
It was
Mouse
Thursday
thing
night,
here.
right?
there we go. There's the first one.
And then if you go down to, again, just above the 20 in 2021,
About here?
right there.
That's the same
I want to know
crater.
what that light, what is that lovely, is that part of that Bailey's?
This is the edge of it, I
White,
think,
that
isn't it?
white
Yeah.
dot.
The white dot is a craterlet. It's the rim of a craterlet within Bailey.
Within Bailey. That's
Yeah.
amazing.
One of the things that I'm always so fascinated by is that when you do these things, you see bits that are outside of, there's shadow between,
Mhm.
Yeah.
and they look like they're floating outside,
It
but it's
just,
just the way the sun is striking the higher parts.
that's amazing, John.
It is, isn't it?
Just for people to orient themselves, that trio of craters just outside Bailey,
Right here.
yeah, those are the landmarks to see Bailey. Even when it's really up against the edge, those three are very distinctive. And then a bit above that, you have that kind of keyhole one. That's Schiller. That was a grazing,
Mhm.
a very rare grazing crater. So most of the time craters look circular. It doesn't matter what angle it came in. But if it came in at under 5 degrees, then you get that sort of elongated crater.
Right. The other thing, this is a different thing altogether, but the other thing that I love to see in these pictures is this very bright little thing, this little feature here, which is Aristarchus. And the reason I like that is because of its name. Aristarchus was the Greek that is reported to have described how the Earth and the other planets go around the sun long before Galileo and Copernicus and all of the more modern astronomers did.
That's one of the areas I was focused on that night, on the 25th.
Mm-hmm.
I was looking at that, and Plato. And I was noticing the weirdness of the libration in Plato because it was tilted away so that the crater edge looked different, because I was looking for the 4 brightest craterlets in there.
Yeah.
And the seeing out here was way better than you were getting in the city, because I was up to, with my little 6-inch scope, you know, I had a 2.5 time power mate on like a 6 millimeter eyepiece, giving me, I don't know, 330 times or something like that. Or maybe that was with the 1.6 Barlow, one of the two. But it was taking a lot of magnification.
One of the advantages of smaller scopes is that you're less affected by the seeing also.
There's a beautiful valley in between those 2 craters too, that snakes its way out. It looks kind of like a cobra.
Between these?
Yeah.
Oh, nice.
Right there.
Yeah. And it snakes along skinny, and then it gets really wide at the end between the 2 craters. Almost, it looks like a cobra head.
Interesting.
George and Donna, they're not the same depth.
They're deeper than you think.
There's
They sure look
huge range. Good question.
They sure look the same depth.
The weird thing is how circular they are, because the collisions come at all angles, but that is because this is not just like throwing a ball bearing at sand. There's so much energy in vaporization and
the other thing that, one of the other reasons that I was interested in doing this is just that, whoops, pull this up again. It's so interesting to me that even over a relatively short time, the different lighting really changes what you can see or how you see it.
Oh, look at that.
You mentioned one time, Randy, you were surprised that the photographs show up things pretty well in a full moon. Well, they do, but look at how much nicer it is when it's not quite full. You just see a lot more. Anyway.
That was the filter or
that's
not?
That's enough of my stuff.
John, was that with the filter or just straight?
No filter.
No filter. Okay.
Oh.
This was, oh, no, but I do know what probably contributed, Gary, to me getting a pretty good image. It had to do with the fact that I went out I went to bed before I got some of these, and I put on my dressing gown over my pajamas and went out and took the pictures in my dressing gown and pajamas. And that's bound to contribute to a better picture.
I'll try that. Yeah, no.
Yeah, give that a try.
My neighbors wouldn't like it for me.
No.
Well, while we're feeling loony, does anyone mind if I share a GIF that I made a while back?
Go for it, Brock.
Can you see that?
Nice.
Oh, nice.
I did that back in the summer.
Very cool. Very cool.
It wonderfully
that
shows
from-
libration.
Did you do that from Victoria?
Yeah, I did. That was back
Wow.
with my 8-inch Dob. I didn't have my better telescope, so it was
Yeah.
hard to repeatedly get the same
Yeah.
sort of orientation and stuff. I did a lot of Photoshop messing around to get everything lined up.
That's
but
really neat.
It's
it's kind of fun.
wonderful.
Very
That
good.
one really shows the effect of the Terminator going across because the crater's almost
Doesn't it?
vanished.
Yeah, and I couldn't
That's
finish it because we just got a bunch of cloud, right? It was right near the end of August, I think. And then cloud came in and did me in, but
Is each frame a day apart, Brock?
yeah, it was basically roughly the same time of day or the night for a number, like three.
Did you have a fixed way of fixing the telescope and camera on the same angle each time, or?
Well, I didn't. That's part of the problem is with my
Yeah.
Dob. I
didn't
made
do-
a little adapter for my Canon to sort of fit into the focus tube, but it tightened in with threads and I couldn't repeatedly get the rotational setting
Yeah.
because when you do the bayonet mount, you rotate the threads, and
I had
I
the
was-
same problem.
with my new setup, I can probably get a better job.
Nathan, you could do that with your set of pictures.
Absolutely.
Mhm.
I was out on that night that we, when we did the shots for that, I was also doing the Nova shot. I had my Dobsonian out as well, just getting some moon shots. So it was kind of fun.
I
Mhm.
think that is Schickard, the big one there.
Yep. Let's see.
So that's just a natural drift, right, Brock?
Yeah, that's just with the Dob, and it's just the moon moving through field of view.
Yeah.
So, and that's what those other ones I did were just basically with that GIF was essentially a series of shots with the Dobsonian single frame, no stacking or anything. But I don't think I knew what stacking was back then.
I thought you might have had the GIF going and then the ever given stop the Terminator.
Mm.
Okay, and any other thoughts or comments before
John?
we wind up tonight?
John, I've got a
Yes,
question.
Reg.
The Scientific American article, is that for 1 month or is that a special edition on
It's
black
a
hole?
special edition. They call it a special collector's edition, winter 2021. And I picked it up in Boland's, and they had a stack of them. They had a huge stack of them. So they're expecting to keep it on the shelf for a while, I would think.
Excellent, thank you.
Yeah, I'll just show it to you. Can you see this?
No, it's in a black hole.
It's in a black hole. Oh, it is in a black hole. Yeah,
We should purchase
It doesn't
one
look
for the
like a
library.
face.
It's because
Oh,
of
I
the
see
Bring
light.
it back to your face, yeah.
Anyway, it actually is mostly black, the cover.
Could we purchase one for the library?
It would be a really good idea because the people that wrote the articles in this case, it's a real collection of some of the best people working on this stuff. And so they're excellent articles. These guys are doing their best to make it accessible, but they're certainly not scrimping on the real science either.
So John,
Sorry.
going with about that, what you were just talking about, there is this, I don't know who they are. There's some brothers and sisters, some young people have sent the observing committee the links to these little YouTube videos that they've made, questioning some of the theories of black holes and gravity and parallel universes and such.
Mhm.
It's way above our pay scale.
Mhm.
We don't know how to, they are looking for people to comment on their ideas.
Mhm.
Can I forward you that email? They're looking for somebody who actually understands what their questioning beliefs are. They've just made these little tiny videos that to me are probably wrong, but they're looking for people to tell them.
Are these young people in school, do you think, or?
Yes, oh yeah, they are
Oh,
like
they're not
preteens,
university
maybe
students.
young teens. Oh no, they're not university students.
Yeah.
They're very young people. You know, using observations they've made about regular things
Mhm.
that they've extrapolated to be about black
Okay.
holes and gravity. And I don't know,
Well,
you could do
you can
with,
send it to me. I don't know. I mean,
yeah,
sometimes it's difficult to
crush
respond to
people.
things like that.
They're
The
wanting
truth
responses.
is, though, that science goes forward by having people question stuff.
Exactly.
So it's a good kind of thing to have happen.
They're cute little videos.
Okay.
They're very short. None is longer than a few minutes.
Okay.
And you just sort of watch them in series. They say to get what we're asking here, you need to have watched 1 and 2 kind of thing. So I don't know. It's
okay.
They've sent it to the wrong group of people, but I guess they found us somehow in our email address. And so, you know, our chair sent it out to us, but we were looking for people to have a better evaluation of it.
Yeah, they might want to send it to people at the Perimeter Institute, because
Yeah.
that's where there are people that actually do this stuff.
Yeah, they'll get way too deep of an answer for them.
That's part of the problem too.
They're just looking for a simple answer, I think. And you're a kind person.
Okay. Well, listen, thanks everybody who contributed tonight. I think it was a good meeting. And we won't see you next week, as Chris said. We're going to be off for Easter. Although we might be out by a month, given what Randy told us, who knows? Anyway, we will see you in 2 weeks.
Thanks.
Good night, everybody.
Good night.
Good night, everyone.
Bye.
Good night.